Oh, not early birds. Oh. Ready. Give everybody just a minute or two to hop in. And we'll keep on keeping on. Hello, good morning. We're getting there. So I have a couple things that I want to talk to you guys about before we start doing lecture. So the first thing that I want to get taken care of is is we still need to do something for study hall for April. What are you guys leaning towards? Who wants to do it? Yeah, Sarah says not it. Well, you've already done one, so you're good. So Nick and Sarah are free from being able to be a sacrifice. Tehran says nope. So what I was thinking is we will have just done the security section. So I'm leaning towards one of two things, either getting one of my design heavy people like Lexi to do a design talk about like whatever design thing you want to do, or having somebody do a security one. Those are the two things that I'm leaning towards. And then Diane also says no. All right, Lexi says I will do design. Excellent. Excellent. Let me get the exact date for you, and then we'll schedule a time to meet up and do the recording for the video, and we can do that anytime, whenever, and we'll do that. All right, excellent. Thank you so much. Let me tell Chase that, and then I gotta write the thing. Carlos, you can't ask questions if you're gonna be late. Lexi just got a 1,000 in my class because she volunteered for something. 3 minutes, 3 whole minutes, and that's what you missed. Oh, I'm trying harder than last week. This is true. You're much earlier than last week, and I appreciate that improvement. That is true. And then listen, next week you guys got nothing going on. All right. All right. Cool. All right, so that's handled. Thank you guys. I think that's the 16th. So it'll be Thursday the 16th is when we'll do that. We'll probably do Google Meetings so we don't have a horrendous time like last time. But you know, that was a learning experience. So there is that. Update on scheduling that I want to talk about really fast is at this current point, I know that our esteemed president has said that he wants everything to be back by normal by Easter. I don't think so. I think that is very overly optimistic, and I think that's going to put a lot of people at risk. I don't foresee us coming back right after spring break. I don't see that happening. Could be the case. I don't think so though. I think we're still going to be remote probably for the rest of the class. I still don't have an exact graduation plan yet. So like maybe we'll just push graduation back a week and then we're able to do it together in a physical space, which is what I really, really want. But I'll let you guys know what is up. Because I mean, maybe May's optimistic and maybe we can do that. We'll see. I do not think that this will be done by Easter though. So that's where we're at with that. And yeah, you know, be safe, guys. Always take everybody's opinions and thoughts with a grain of salt. Like if you hear somebody say something whack, be like, maybe that was a weird thing to say. You know, me included. If I say something, you're like, you can be like, Maureen, that was weird, and I will accept that. But yeah, so I just want to let you guys know what's up with that, and that, you know, I value you guys' safety more than, you know, that. So moving on. Well, any questions about study hall for April or what our schedule is for, we'll definitely be remote this week, and then next week is spring break. I don't have anything for you guys over spring break. Catch up on work if you guys want. Work on professional development stuff. Take breaks. Sleep. Get portfolio together. Yep. Cool. All right. So I wanted to quickly touch base on Donna's talk on Friday. Does anybody have any questions, opinions? Diane says I may actually have to work. Yeah, this, like, I was gonna take the spring break off, but I will be working this spring break. So like, if you are working and have questions, I will be online during like normal like business hours. I mean, it'll probably be more like 8 to 4 than 9 to 5. But yeah, Carlos says I might not go to work next week. Take an actual vacation. Take breaks, man. It's good for you. I remember when I was in college. So I worked like 2 or 3 jobs most of my college career, and my senior year of college, because I worked the master's every year and then I would still work my regular job too. Well, but my senior year, I was like, you know what, I'm not doing this anymore. So I only worked 20 hours my senior year spring break. It was the most primo vacation I had ever had in my life, and I didn't even go anywhere. Because normally I'd go work like 80 hours at the master's, and then I would go and work like 30, 40 hours at my regular job. So that 20-hour work week was like beautiful. But yeah, so take breaks, they're important. Cool. Do we have any questions about resume stuff, job interview stuff, the online application process, anything like that? And then also consider like all the stuff Wayne talked about in the beginning too, and that government jobs are different than civilian jobs. So any questions about that? And again, I'm willing to write reference letters. I'm willing to proofread resumes. I'm totally willing to be a reference for you guys, all that stuff. I'm here for you. And that goes for anybody at the clubhouse. Like, you know, if you want Chase to read over stuff for you, he probably will. Can I put down his email in Slack? Yes, I can, because I said I would and I did not. That is in Slack. I like that one a lot. And remember, you guys are Augusta Tech students, so you have full access to all of their career services. Resources, I guess is the right word, career services department. Well, any other thoughts, questions, opinions about study hall or schedule or Donna's talk from Friday? All right. This Friday, I'm emailing with one of my other teachers. Like, she teaches at Augusta University, and so we're emailing back and forth. Typically, she does an ethics talk for me, and it's like one of like my students' favorite talks. Like, they really enjoy it. So I'm hoping that she will be able to do that on Friday for us, so you guys will get a guest speaker. It is a really interesting talk, and it's a lot of fun. Yeah, it'll be about like ethics and computer science, and like, you know, I think it's cool. So I'm hoping that that'll still happen. I don't see why not. She seems pretty flexible, so that should still be a thing. And then Friday afternoon at 4 p.m., your guys' group project is due, and then you guys are gone for like a whole week from like 4 p.m. Friday until like 9 a.m. the next Monday. You guys are free, which is exciting. Yeah, so that's what's up. Any questions about schedule, what's going on, what I want from you guys, anything like that? All right, cool. Cool. One other thing that I do want to talk about, as I was like looking at stuff, when you guys commit code to anything that you're sharing with other people, make sure that you're committing things in small chunks that are commented and tested. So like, let's say like you've been working for like a really long time on something, and then like you have like 400 lines of code. That's a pain to try to like get someone else to read. So if you can do like little chunks of tested code and explain what you're doing, that makes it a lot easier for other people to integrate with you. And like, this is an issue that like even professional developers have. I don't know if you heard, but Chandler was sitting like here on Friday with me, and like I don't know if you heard him like groan and scream at like some point during the day. And that's because someone committed a pull request with 50 file changes. So not like 50 lines of code, but 50 files had been opened and edited. That's a sucky pull request to read through. So little tiny commits. And you know, that's professional developers who are supposed to know better. So, you know, just keep it in mind that that's not what we want to do, because that leads to other people screaming. And he looked at me and was like, I'm going to tear this pull request apart, because that's way too much to do. And so they're not going to be happy with you. So little tiny pieces of tested code. Sometimes it's unavoidable and you got to do a bunch of stuff, but the smallest pieces you can make, the better. Cool. All right. Alrighty. I also, yeah, so Taiwan asked, the system doesn't have a way to stop that from happening, like a limit. Nope. Any kind of version control does not care what kind of code changes you make. You can change every single file in the code base, and things like GitHub, SVN, they don't care. They'll just tell you. Diane says, I'm not sure how to do this, but I would doubt I will ever write anything that large. Yeah, so it's just, and exactly, like that's weird to think about that scope of like working with 50 files at once. That's crazy. And like the pull request got denied because there were a bunch of mistakes because it was too big of a commitment. So exactly, like you probably shouldn't write something that big because it's going to break. You know, you probably need to make it into smaller chunks for each individual piece. So yeah, sometimes you will have like CI/CD pipeline limits set up, so that way those kind of systems can help you not have those issues. But like GitHub by itself does not care. You can change every single file in your code base and it'll just be like, looks good to me. But yeah, so you totally can happen. And GitHub or Atlassian, whatever tool you're using. Dan says GitHub's not working. So, you know, it limits it that way. There's not a limit. And it's not really like a number limit. It's more about like logical limits. So like they should be able to like be a succinct sentence or two saying what you did. So like, you know, when you write a commit message, the commit message can only be 50 characters or less. So each like little chunk that you commit should be able to be succinctly described by that. And so sometimes maybe like, you know, if you're doing just HTML, that might be a huge commitment to like make and be like, yeah, you know, this is like 400 lines of code, but it's all pretty simple HTML. And so you can be like, created homepage based on specs. And you know, you just made the HTML for a homepage. That's probably totally reasonable to send because another developer can look at that and just check all your HTML and then it's like, bam, okay, that works. But like, you might only commit like 3 lines of JavaScript because it's like a complicated function and you're like, you spend the whole time being like, this function checks tax rates based on blah, 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 and you know, you spend a lot of time explaining what that function does, then that should probably be by itself. So it's more about like a logical limit than like a character limit. Kind of like when we talked about agile development and tickets versus stories, you probably only want to commit like a little bit of work for each thing, not the whole piece. Yeah. Yeah, because GitHub doesn't care. GitHub will be like, yeah, man, you can, you know, commit like an entire operating system worth of code. And it's just like, cool. You got it, fam. SVN's also really bad about it too. But yeah. Yep, and then you always want to make sure that like you're committing code that at least won't break. Might not be perfect, but you know, we won't break. But yeah. All right. Cool. Oh, also, so you guys know I don't ever like advocate for you guys to commit any kind of crime. But tell you what, Sunday afternoon, there's nobody at the cyber center. So if you ever want to get up to anything, that's the time. Because I went there Sunday and I had my badge, but there was nobody at the front desk. So I went and I got that's a dry erase board. Yeah. So anyways, see, I did think I was gonna have to write backwards. So I'm gonna have to write backwards. So I got the big dry erase board now. And I'm gonna have to write backwards, but that's okay. I'll figure it out. Or I'll figure out how to flip my camera. I don't know. Does it fold? Okay, so how did I get it into my car? Is I stood outside for like 15 minutes taking the entire thing apart. And that's what I'm saying, man. So I walked in, there's nobody at the front desk. I go in, I come take this giant thing, I take it out, and I have it laying on the sidewalk as I'm pulling everything apart because it has all these weird little connector pieces. I'm just like, come on, man. Somebody should be at least like, what are you doing? But no, no questions, nothing. So all the writing is normal right now. So, okay, awesome. Okay, cool, cool, cool. Good to know. Because like when I look at my little screen thing, it looks backwards. But if it's readable to you guys, I will just continue to write like a normal human. I also stole an eraser, but I don't know where I put it. Which I guess isn't shocking, all things considered. I think it might be my car, but that's okay. I'll just use my hoodie. Awesome. But yeah, so that was a fun adventure. But yeah, you know, you want to go commit cybercrime, apparently Sunday is the day. And I'll use a black marker so you guys can see what I'm doing, and I'll try to write pretty big. And then it looks like all the recordings for up to Friday should be there. I'm pretty sure they're all uploaded. So Jamila asked about all that. Yes, so that should all be uploaded. I'm pretty sure I did. Yeah, let me know if I didn't, but I'm pretty sure I uploaded everything up until Friday. So like everything should be good. Cool. All right. Excellent. Um, so Venus says she can't hear me, but the rest of you guys can hear me, right? Okay. All right. So I think one more thing that I want to talk about before we get into more new content is like, I think I've talked a little bit about testing, but I haven't spent like in-depth time about it. So when we talk about testing, there's a couple different um, flavors that we want to talk about. So the first thing is like, will it compile? So like if you run it, you know, like you open LiveServer and you run it, or you node run it, whatever you do, does it actually compile or does it throw errors? So that's like your first base level of testing. Like, do you get errors when you run it? Obviously, if we're getting errors, we shouldn't commit it, yeah? Yeah. The next level of testing, so like, okay, we write some code, there's no errors in it. Awesome. If we were in like a well-developed pipeline thing, we'd probably have unit tests too, which would give us a little bit more information, but we haven't really worked with those. Like we've talked about them and that's it. Our next thing would be to make sure that our code doesn't break someone else's code. And this is what we call like integration testing. So like you look at your code and make sure it's not going to overwrite anybody else's code and that kind of stuff. So then when we commit our code, we're not breaking other people's stuff. And it's kind of like our same thing, like when we've done like just individual projects, you know, like as you add stuff to your code base, we want to make sure that it's not breaking other pieces of code. It's a big bird. It was like a vulture or something. Anyways, but yeah, so just be aware that like code should compile before you commit it at the very least. You probably want to do some more in-depth testing and spend time thinking about like, is this code clear? Does it make sense? Is it meeting all the standards that I have? But at the very least, it should compile. So it doesn't mean that there's no, that like checking that there's no syntax errors is a good step, but like you want to make sure that like you can run your code and it does what it's supposed to. And it doesn't have to be like a hundo P, like the best code ever, but you know, commit it that compiles and does the thing. Like if it's like, you know, change color on button click, it should change color on button click. Wonderful. Cool. All right. So let's look at some stuff. I'm going to flip to, well, actually, I don't think I'm going to actually flip to a screen share because I want to spend more time on the whiteboard. We're in week 9, and then if you pull the syllabus, we're on the CS data structures piece. We're going to talk about stacks, queues, and hash tables, and then hopefully start search algorithms today is my goal. Yeah, I think so. Okay. All right. So sometimes when we use data structures, what we really care about is, I also want to do, let me get a marker real fast. So when we talk about data structures, one of the things that I also didn't put all the zip ties back, so it might move a little bit. All right. I know I do need a housewife. I don't have either of my housewives today, though. It's very sad. Normally, I had at least one hanging around. But I don't have any housespouses today. All right. So you guys can see the board from bar to bar and then like about this high. So I'll write everything in between and then I won't go higher than this. How low can you guys see? Here. So when, and then I think I need to write a little bit bigger than usual, but you guys should be able to see that okay. So I'm gonna stand back so you guys can, like, there we go. I feel very like, I don't know why this feels weirder than sitting in front of the camera, but it does. So when we talk about data structures, one of the things that we do with them is we want to kind of build rules, and that's why we pick different structures. So like, you know, in an array, we don't really have a lot of rules. We can pull data from wherever we want. We can add data wherever we want. They don't have any like relationship to each other. And most of the time that's fine. That's not a big deal. We can just kind of have it do whatever and it's fine. But sometimes we really need that structure so that way we don't have to do as much work. So like, for example, let's say you were building, you know, like a back button for a browser. You don't really want to put it into an array because then like things could get messed up really easily. So we can use a different data structure to help us have a little bit more rules. I'm going to put my glasses on real fast because I cannot read the chat. So it'll be great. Okay, much better. Okay, so one of the data structures that we have that can really help us with that kind of, I don't want to say structured approach, but like applying rules to how we interact with our data is called a stack. And this is one of like our fundamental data structures. So we have a stack. You guys see that, or is that too small? Do we need to write bigger than that? Good, okay, awesome. So a stack kind of works like an array. So like if we draw an array to look like this, you know, all of our data goes inside of here in our array. A stack is basically the same structure, but instead of being sideways like this, our stacks look like this. And what is the big structure behind a stack versus an array is that we only work on this very, very top piece. So we can push stuff on top of the stack, and we can pop stuff off of the stack. But if we want to get this piece all the way down here, we have to pop everything else off. So like this is kind of like a real world thing. So like, you know, like we had a thing of like tennis balls. If we want this tennis ball, we have to take this tennis ball off first. Or like a stack of plates or cafeteria trays. You can only work with this top piece before you get anything else out of it. Legos. Yeah, kind of like Legos. Like if you stick a bunch of Legos together, you can only take the top Lego off. So, okay, that's cool, I guess. Like, why do I care? We care because using this kind of structure gives us a lot more control about what's going on. And this is also called a FIFO data structure. So what that means is first in, first out, right? The first in, last out. I always get the letters mixed up because it doesn't super make sense in my brain. Yes, because the first thing that you put in gets buried on top of everything else. Yes. So you'll see first in, last out, and first in, first out. So Venus asks, it's how JS reads code, kind of. Kind of. It'd be more like if you were like browsing like a stack of photos or something and adding stuff and taking stuff away. So kind of, but not exactly. But that's not too bad. And we also have letters in, last, out. And then we also have, I'm just going to put a little star, we'll talk about this more later. We have first in, first out. So this is kind of weird, but like what kind of things would make sense that we need to handle things not based on like you know, when we go to like the DMV, the first person who goes in is the first person who gets served. So what kind of things, what kind of things would we want to use this kind of structure for? Because we have a couple like physical real world things that we use all the time with this. So what would be another thing that would be, so I would follow this kind of stacked structure, right? So Sarah says math. Okay, okay, I'm with you. Yeah. Sharon says packing. Sarah says like adding previous numbers to the next. Venus says a lexical environment. I don't know what that means. Yeah. So like packing, that kind of stuff. Some digital examples that we think about with stacks are like a history. So like, you know, even like our version control kind of has a stack. All right, Venus's placement to other stuff. Are you saying like local environment versus like a global environment? Storage, the first thing you store is probably the last thing you'll be able to get. Yeah, yeah. Browser movements forward and backwards, exactly, yeah. So like we can also think about this as like version control too. So like as we commit code, so we make our first commit and then we make our next commit and we make our next commit, and we only ever really work with our top most recent thing. We do want to keep all these other things, but we're typically only working with the top. So that's some of the ways that we use our stacks is for version control, browser history, anything that has a history to it, we're probably using a stack data structure. These are used in like almost every single programming language. This is how your physical memory works on an operating system, whether you have an SSD or hard drive, is stuff gets added to the stack and then you take stuff off as you go. This is how like databases kind of read and all that. This is how we do a lot of our memory allocation in other programming languages. And this kind of data structure doesn't have as many rules as, remember how we talked about how linked lists have to specify their size? Stacks don't have to specify their size in almost any language. So that's why we get our wonderful thing called Stack Overflow. Is when we've added too much data to our stack and it starts to overwrite other pieces of memory. And that's because it doesn't have any hard and fast set size rules like a linked list. Why do we think that like a Stack Overflow error would be like a really bad thing? Why do we think that we got a whole website about fixing coding problems dedicated to Stack Overflow? So Sarah says it will forget the old data it needed. Something will break. Yep, yep, yep. What if, so remember like our physical memory on an operating system, you know, can be represented like this and everything has an address. So let's say this is our stack that we said we want to put code in, but this stack right here is like the fundamental key parts of our operating system. So if our data from our program overflows into here, we can overwrite parts of our system. This is a lot harder to do now. There's normally a lot of like safeguards in place, so it won't overwrite stuff like this. But Stack Overflow exploits can get like your entire password files to print. It can make critical errors in any kind of like system. So Stack Overflows are this big kind of error that goes on. And just because like we don't necessarily use, you know, a specific thing called a stack in JavaScript, like normally it's like arrays and that kind of stuff. We can still get these kind of data overflow errors, even if we're not necessarily using this exact structure. But this is a really nice way to think about why this kind of stuff happens. And then in other languages, we do get this like exact error. So, yeah. All right, so Venus says it's also harder to find the error. And then it doesn't take memory space like JS. Yeah, so it does, JavaScript. So because JavaScript is not compiled directly to machine code, it's not necessarily allocating direct memory space on your machine. So you don't tend to get hard errors with the Stack Overflow like you would in other languages. But since we do use Node as our backend language, you can still get these kind of hard machine errors too. There are also a lot more safeguards in place now with any kind of coding to not have critical failure errors like this. But even in JavaScript, even though it doesn't compile directly to the machine, this can be a huge security vulnerability. And we'll talk about the biggest security vulnerabilities and what we can do to code against them when we come back from spring break. But yeah, that is a good point. It doesn't necessarily, JavaScript doesn't necessarily like hard define machine space, but these kind of issues can still happen. Cool. I'm adjusting some stuff so I know. All right. So any questions about this? The whiteboard is primo. Yeah. All right. Well, I'm glad it was worth it. It is very huge. It makes my apartment feel very small, but it is all good because I have a fireplace wall and that's pretty useless right now because it's hot. So we'll just put it there and it's my decorative art piece. I'm glad though that this is worth it for you guys because I think it's a lot easier to draw on this too than to draw with my tablet and try to screen share and all that. This is much easier for me also. All right. So I will think what I want to do is I want to go over all three of these things on the whiteboard. We'll take our break and then we'll look at code is what I think will be the easiest way to flow through and do all of this. I did grab an eraser, but I genuinely don't know what I did with it. I'm gonna check real fast and see if I put it in my purse, and then if not, I'll just erase it with my hand again. So I'll be back in just a second. I'll know what I did with it. I did grab one. All right, so I'm gonna erase this. If anybody wants to take like a screenshot or anything, I'll give you like a couple seconds. Okay, I'm erasing it then. So we'll look at all this in code and we'll talk more about this first in, last out kind of thing. This next data structure, I think, will be a lot easier to understand because we use it a lot in real life. And I get to tell you guys one of my favorite bad jokes. So our next data structure is called a queue. And we've all seen queues before. Anytime, like waiting in line, that's a queue. We've seen that before. So, you know, someone asked me, why does queue have all these extra letters if we only need this one? They're waiting their turn to be pronounced. It's my favorite bad joke. I literally like got a marker thrown at me when I said it before. It's my favorite bad joke. All right. And so our queue structure looks a lot like our arrays. And so all this means is that, so with our stack, we work just on the very top one. This one works more like this. So it works more like, you know, a line at the DMV, a line at the movie theater, anything like that. So our first person in is going to be our first person out. And we use this kind of data structure a lot more in real life. And so I think it's a lot easier to understand when we use this in coding. So what kind of coding things do we think we could use this kind of data structure for? Tickets, yep, we can use this as part of a ticketing system. Orders, we can process orders first in, first out, yep. Those are both pretty good examples. So yeah, these are, I think, a little bit easier to understand, and I think we can think of like better cases for queues. You can also have circularly linked queues, which I think is kind of weird, but basically we just say like, go like this. This structure doesn't get used a lot, but it's just a way to make sure that that way we don't have any like overflow issues. We wrap the queue around itself and have an end and a beginning. And then as things go in, they fill in like this. And then things go away from the end. And now you can totally like overwrite things and end up with issues that way, but it only will break things in this little system versus breaking your entire program. We don't use it a lot. It's just a way to make sure that we don't overwrite the whole system if that's what we need to do. Cool. Yeah, I don't think queues are too bad. I think they make a lot of real world sense. So any questions about stacks or queues? No. Okay, let's look at let's talk about hash tables, then we'll take our break, and then we'll keep on keeping on. So this is going to get into a little bit more math than what we have worked with before. So again, this isn't a math class, no stressing about it. I just want you guys to have exposure to this and understand how this works. And we'll spend more time with it during our security week, but I want to set you guys up to understand this structure. Sometimes it's not enough to store data all directly together, just stacked or queued on top of each other. Sometimes we have to do some more complicated movements, especially when we're working with data that has to be encrypted, or when we're not really sure what our system looks like to save data in. So like, let's say you're sharing resources with like a cloud server, or you're using a really old machine and you don't really know what the memory management looks like. Sometimes you have to be a little bit creative with how you store data. And so one of the ways that we can do that is with this concept called hashing. And we're going to see this in the form of a hash table. So fundamentally at its core, all hashing is the same exact thing as like mapping. We're going to take all of our data that we want to store and apply some kind of function to it, so that way we can store it in a new place. So a hash is a function, and we mean that in like the mathy way, not the JavaScript way. So any kind of math you can do. A hash is a function applied to data. I'm going to add a caveat here for what our specific definition is, but understand that this is just kind of what it is. It's a function applied to data is all hashes. Sarah asks, is it related to a hashtag? I don't know, actually. We're going to put a little hashtag up here. Because originally this was called an octothorpe, is what the engineering term is for the pound sign. This is an octothorpe. So I don't know why it's called a hashtag, and I don't know if it's related to hash math. So we'll take a look. Because we use it to find all of the data that's under a hashtag. That makes sense. It could be. I just don't know for sure. We can find out though. We will put that on our list of I want to Google it when we take a break. So we will Google it and do some research and find out. Because I don't know. So this is what our most basic definition is, but I want to talk about it in the specific context of storing data. So I'm going to add a little bit to this definition, but do understand that this is just what a hash is. A hash is a function applied to data. And in this case, so we can store it in a unique location. So I'm going to stand all the way over here. I think that's so you guys can see the whole thing. I underlined unique because that's the part that we really, really care about. Because that makes sense, right? We don't want to store two pieces of data in the same place. So a good hash function makes sure that every single thing that we apply to it is going to be unique. So let's think about it. So all right, Venus asks, will this help with not having to create string for SQL security? No. This is for, you can use hashing to encrypt data, but you still want to do all of your validation and all that on the front end. This is for back end stuff. This would be once you get the password logged in and you don't want to save it in plain text, you can use a hashing function to encrypt it and then save it. So let's think about what a bad hashing function would be that wouldn't be unique. Obviously if we don't do anything, that's a bad hash function. So we add 0, that's not gonna work. Or maybe we want to change, we're using strings, and we want to encrypt it by using the ASCII values and adding them all together. That seems like a pretty good one, right? That should be unique. But we wouldn't know that for sure until something broke. So I don't really have the ASCII numbers in the top of my head, but let's say hello ends up when you turn it all to the numbers and add them all together, you get 4,000. But we could get 4,000 with addition and any other combination. So that's probably not going to work. So typically hash functions have multiple steps to make sure that we avoid collisions. I don't have to spell the word collisions, guys. You know this. Now, collisions are not always unavoidable. Because you could write a really good hash function, but not think about edge cases and things can happen. Diane says wreck. Yep. So what you want to have in this case is something that you do next. So let's say our hash function is, add 1. That's our hash function. Wonderful. Nothing's going to go wrong with that, right? So then over here, we create our hash table. And I'm going to say this is 0, 1, 2, 3 is our locations. And then over here, we're going to like have some data hanging out. So maybe we have like 10. We can even have like 10 again, 11, and maybe like 14. So we have all of our data that we need to store. And then we have places for them to go. So we say, all right, well, to get them to our new place, we're going to add 1. Actually, let me think about it. Because I want to come up with something that'll break so we can see what we do when we break it. So -1, 0, and +1. And I don't care about this guy now. But yeah, so our magic super secure hash function is just adding 1. Okay, so cool. All right, so -1 + 1 is 0, so that's where we're going to put that guy. Great. 0 + 1 is 1. Yes, that's great. Oh, that's 0. Woo. And then 1 + 1 is 2, so that's great. So far, so good. Everything's fine. But like, what if I put in something like, you know, I had a repeated data value, and so I have like another 0. Well, okay, 0 + 1 is still just 1, but I already have something in here. So that's when we get our collision. So we have a couple different options. Option 1 is we can just reapply the same hash over and over again. Option 2 is we can have a new function for each time we have a collision. Let's just say that our new function is just going to be the same one. So, okay, so 0 + 1 is 1. Okay, well, let's just add 1 again, and then we get, or I'm sorry, 0 + 1 is, ooh, my brain just totally stopped. Oh, because I did 1 + 1. Okay, sorry, my brain just totally hard crashed. 0 + 1 is 1. We already have something in that memory location, so we're going to apply our function again. So 1 + 1 is 2. Okay, well, I still have something here. So I have to reapply my function because we've had another collision. Okay, we're here. Wonderful. And I'm going to put like, I don't know, this. I don't even know which one's which. Typically, hash functions are, the encryption videos talk about this, but like they are easy to perform one way, but really, really hard to perform backwards. So like logarithms tend to be what kind of function base we use because logarithms are really easy to solve one way, but they're really, really hard to figure out the other way. The videos do a much better job explaining it than I will, and like this is not a fundamental piece. Just understand that a good hash function reduces collisions and is easy to do one way, but maybe hard to do the other way. And we apply it always in the same order so that way we can go back and be like, okay, well, I want to get this piece of data here. We know exactly where it is because we apply the same things each time. This is not necessarily encryption by itself, but you can use hashing to encrypt your data and get new things. Or you can use it for like generating secure tags. So that's what we saw on Friday for a little bit. Some software will have an MD5 tag. And all that is a little piece of hashed information that you can compare. And because it is a good hash function that it's really hard to fake it and go backwards, you know that if your two hash values are the same, that you have the correct version of the software. So that's one real world example of it. Hashing by itself is not encryption, but it can be used as part of an encryption suite, and it can be used as part of a data structure so that way we make sure that we're never overwriting data. So those are stacks, queues, and hash tables. How do we feel about those? We're going to dig into some code and go over all of it too. But like as like a top level, like If I asked you what a stack was, do you think you would tell me? Need more on hash? Okay. You want, because we're going to do it in code too. So like, do you get this part that the hash is a function applied to data so we get a unique piece of information? Cool. All right. That's all I want so far. Yeah, it'll be easier once we see the demo, especially the hash one. I think it makes a lot more sense to look at one real world one. And we looked at one like very briefly on Friday, so I'll probably pull that back up so we can look at it, and then we'll look at some code too. But right now, I just want you guys to have like a definition level of it. Like, you can visualize what a stack looks like, you can visualize what a queue looks like, and you understand the idea that sometimes we have to transform data to store it. That's where I want you guys to be right now. All right. How are we feeling? G2G, wonderful. All right. Monday, I'm feeling Monday. Listen, my dear lasagna cats, Mondays are fine. It's all fine. We only got a week and then we get spring break. It's going to be good. The sun is almost out today. It's wonderful. All right. Let's go ahead and do our break. We'll come back at 10:20 and we will do a bunch of code demos and spend a lot more time digging in depth with what these are. So I'll see you guys back at 10:20.